Definition 7.1 is going to define for us the average rate of change. And the average rate of change is always describing a particular function, and we're always describing the average rate of change between two particular x values or two particular points that are on that function. So the definition here says we'll call the first x A, the second x will be b, and really all the average rate of change is a slope calculation. So I'm going to jump to the note here. It says the average rate of change is slope of the secant line, specifically between x equals a and x equals b on the graph of f. So if you're looking at example 7.1, we drew two secant lines. We called them L1 and L2, and those secant lines each have a slope. So the slopes that you calculate in part D of example 7.1 represent the average rate of change of f from 1 to 3 and from 4 to 6. Those are our two different average rate of change calculations there. So since it is so closely tied to the idea of slope, you'll notice that this formula here has delta y divided by delta x. So I'm going to abbreviate average rate of change as AROC, A-R-O-C. And since we can think of the average rate of change as a slope calculation, then we should also be able to think of this as a y2 minus y1 divided by an x2 minus x1. So really we can think of where it says x equals a, we can think of that as being really x1, and then x equals b is really x2 is equal to b. So we can use the notation that we had previously from linear functions and slope, and we can just adapt it here for the average rate of change.